This is a video to help you finish Lab 4. So the first thing we'll do is question 4.2. We'll use StatDisk to simulate 1,000 rolls of a pair of dice. So to do that, we go to Data, Uniform Generator. We make this 1,000. We make the minimum 1. We make the maximum 6. We make the number of decimals 0. There's no need for anything here for a random seed. And then we'll select column 1 to generate our data. And so here you can see that these are random uniformly generated sequence of numbers between 1 and 6 to simulate one roll of a six-sided dice. So now you do the same thing again. So we keep all of these the same, and we might change the random seed to make sure you get different data. And then so then we'll go to column 2 and we'll generate the numbers there. Okay, so now what the question is asking you, so we go back here, is sort the results and then find you want to simulate the roll of a pair of dice. So we want to add these two numbers up here. So you want to add this number here and put it here, this number here and put it here, and this number here and put it here. So so what we'll do to do that for these 1,000 rolls here is we'll go to Data, we'll go to Sample Transformations, and then we'll go to Advanced Transformations and do column 1 plus column 2. So that's the syntax you want to use. And then we'll go to 3 for the transform data. Okay. So you can see right here in column 3 are the sums of the numbers in the first two. In this entry here. So 6 plus 3 is 9. 1 plus 1 is 2, and so on and so forth. Okay. So then the question is asking you, well, let's sort the results, and then find the number of times the total that was exactly 7. Okay, so we go here. We'll go to Data Tools, Sort Data. We'll sort again one column, and then we'll look at the transform column, and then push sort here. So you can see right here, you can see the number of times 2 showed up, which will be 1 to, in this case, 1 to 30, right? So that's, in that case, 30. And so then now, that's 30 rolls. And so now what we'll do is we'll go to 7 and see how many times 7 showed up. So you can see 7 shows up, begins at row number 439. And then we'll go all the way up to 439 to 605. So you take 605 minus 439, and that will give you the number of times 7 shows up. So you take that number and you put it here in your first answer. So again, so I do want to point out that whatever data you see here in this kind of sample lab and whatever data you get in your own lab will all be different, because again, this is random data. So I ran this earlier, and a sum of 7 showed up 180 times. And I found that by using the same method that we just talked about. Okay, and so once we have this, then the next question you want to ask is, okay, based on the result, estimate the probability of getting a 7 when 2 dice are rolled. Again, we're adding the 2 numbers together. We'll enter the estimated probability here. So again, it's different with this data generated here. But here, in the simulation I ran earlier, a 7 showed up 180 times. So that's going to be 180 of 1,000. And so that's going to be 0.18. Again, what your result will be different. So then the next question says, how does the estimated probability compare to the computed theoretical probability of 1 over 6 or 0.167? And the relative frequency of 0.18 is close, within 20% of the theoretical probability of 0.167. Okay, so again, this answer will be different here, and of course, this number will be different for you, and this number will be different for your lab. All right, so let's go on to question 4. So this is a problem involving birthdays. So we'll simulate a class of 25 birth dates, again, excluding the year, by randomly generating 25 integers between 1 and 365. We'll ignore leap years. So, and then we'll arrange the birth dates in ascending order, and then examine the list to determine whether at least 2 birth dates are the same. Again, this is easy to do because any 2 equal integers must be next to each other. So, okay, so we'll clear all of this. And we'll go back to, in this case, we'll go back to a uniform generator. We're going to look at a sample size of 25. We'll look at a minimum of 1 and a maximum of 365. So this 1 corresponds to January 1st. The 2 would correspond to January 2nd, the 3 January 3rd, and so on. Okay. We don't need to put anything for a random seed. We'll put the number of decimals as 0, and then we'll select column 1 to put the data. So we generate this. Okay. All right, so these are, again, birth dates, right, which correspond to these numbers here. And so then what we'll do is take that data of generated birth dates. And again, I did this earlier. So of course, again, as this is random data, this is different than what you'll get. But you'll put whatever numbers you get here, and I just cut and pasted into the lab right here. So what we'll do here is let's see if this group of 25 numbers have any numbers that are the same. So once again, we'll sort the data, one column, using column 1, and then we'll sort. And we can see right here, let's see if any of these numbers are the same. And we see, yes, there are. 309 are the same. And so the next question says, are at least 2 of the birth dates the same? And in this case, yes. And in the previous data I generated, the number 61 and 61 were the same, and so at least 2 of the birth dates are the same. So the next thing you want to do for 4.45 is do the same thing 9 additional times. Okay? So you do that 9 additional times, you record, you answer the question, are at least 2 of the birth dates the same? And just to point out, you can of course just do it here. Let's change the seed right here. We'll keep everything the same, and then we'll select column 2, and we'll get a new group of birthdays here. And you can go to sorting the data. We'll sort column 2, and so on. And you can see for the second run of these randomly generated birth dates, you can ask yourself the exact same question: are any of the birth dates the same? And here you can see yes, they are. So they're right here. So if you find, in this case, there are 3 of them that are the same, and you just leave it as that. And so you would say yes. So in the data I ran before, this was no. So I just put no there. But in this case, it would be yes. And then we can do the same thing. I'll change the random seed right here. We'll select column 3. We'll generate similar data. We'll go to Data Tools, Sort Data. We'll sort column 3. And once again, you ask yourself, are any of these numbers the same? And in this case, no. Okay. And so I'll change that, the random seed, and then I'll go to 4, and I'll do the same thing. And we'll sort the data for column 4. And yeah, let's see if any of these numbers are the same. And no in this case, right? And so on and so forth. So I did this for one group. For the 5th column here, I cleared the data and then did it 5 more times for 5 more columns here, and then recorded yes or no whether any of the 2 birth dates were the same. and I got this data here. Again, your data will be different. And the last question you can answer is, based on the results, what is the probability of getting at least 2 birth dates that are the same when a class of 25 students is randomly selected? Again, that's a simple random sample of size 25. And from the data I got here, as you can see, that's 1 yes, another yes, 2, 3, 4, and there were 3, 4, 5, 6 no's. So the relative frequency there is 4 out of 10, so 40%. And you can ignore this remark, but if you want to know the actual theoretical probability, it's approximately 0.561. Okay, that's